Shrek. Shrek is here. Wow, incredible. Okay, good job, Anonymous. Wow, incredible. Efficient. I like it. Tight schedule. Tight schedule. Incredible. It's 5 a.m. somewhere, right? Wow, let's say. Toaster? Wait, Toaster got it? Wait, Toaster, you're in college? I didn't know that. I didn't know that, Toaster. Wait, you're not one of the students, right? That would be embarrassing. Oh no! Okay. I'm sorry to hear that. But you're always welcome here. Toaster, you're an honorary class member. Yeah, it's online. And there's no cameras pointing at your face all the time. Not here. Not here. We prefer privacy here. That way Anonymous Cowboy can make anonymous comments. Dumb ones. And not feel embarrassment. Damn right. Kappa! Kappa, good job. Incredible. Incredible, Kappa. Hell yeah, brother. Toaster. The bike till the heart explodes doesn't work anymore. So don't, whatever you do, don't click that one. Click any of the other ones. Hmm. Yeah, UB, I know. It's all messed up. It's all kinds of messed up around here. This place does not work as intended at all. Hello, Thor. Welcome. I teach at the University of Twitch. That's right. That's right. Okay. Just ask the informative other members of chat here. We're all very informative, very sincere people. We don't troll. We don't make fun of each other. It's just very informative. Okay, let's go. Let's go. Let's get the music going. Okay. Class, come on in. It's 11:30. We have a couple weeks left in the semester. We're in the final stretch. This semester has been crazy for everybody. And let's try to just keep our spirits up and stay with the program. So part of that involves continuing to just at least attempt the exams. There's an exam today, as I announced on Discord. There's an exam today. 10 problems, fairly easy. Maybe one of them might dupe some people, but the rest, easy. Go ahead and take it. Take the exam. All right, so that's the announcement for today. Class. Okay. So, what's the next topic? The next topic is the topic of power series. And let me see here on this screen that's so far away. When is it due, the homework? Ah, 14th. November 14th. When the next homework's due. Interesting. Okay, let's continue. Next 2 weeks, what we'll do is we'll combine two subjects that we just learned. The concept of Taylor polynomials, which the whole class seemed to have loved this. This is a class favorite. Seems. Don't worry, you get a second chance at showing me that you understand what a Taylor polynomial is. We're gonna combine that with infinite series, which class is pretty good at now. Pretty good at this. I mean, we've had like 3 weeks of it. Hopefully you're good at it. Okay, convergence and non-convergence, geometric series, blah, 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 all that stuff. We're gonna put them together. Who's sleeping? Who's sleeping? All right. We're gonna put them together, and what we're gonna get is a new kind of mathematics. And that is the mathematics of power series. So I gotta explain that, okay? And I'm gonna do a mediocre job, just as usual. Let's start that. What we're gonna do today, I'm gonna recap Taylor polynomials, and I'll do an extended example. Then I'll tell you what a power series is, and then I'll start talking about how to use them. The what is easy. The definition of a power series is easy. The how to manipulate them, that's gotta be earned. And we're gonna earn that this week. We're gonna earn it this week. We're gonna understand the subtleties. Okay. All right, let's do this. Let's dive right in. Dive right in to the material. Okay, number 1. Taylor series. Taylor polynomials. Recap. Remember how this worked? Remember this story I once told you, students? I hope you remember this. You see, on the one side, we have the functions that students love. And I'll tell you, as a math professor, I will tell you exactly what's on this side of a student's mind. There's no debate here. There's only one thing. Polynomials. They don't even like negative powers of x. No, they start flipping out. Forget fractional powers. Forget sine and cosine and tangent. They hate those. They can't even plug things in to those things. E to the x, what is that? That's fake news. Okay? This is the side that students love. They're stuck in 6th grade. All right, this is 6th grade. No, trust your instincts. You're still stuck in 6th grade. It's not just you, by the way. When you grow old like me, you just pretend to like the other ones. But you're always most at home in the polynomial world. And then there's everything else. Is this ringing a bell, students? Just everything. Everything. Okay? What's the opposite of heart? Okay? Everything else. And what was the role of Taylor polynomials? It was to take a complicated function, f of x, the only kind we think about in this class, f of x, and then produce from it a polynomial. What degree? Specify it. You know, nth Taylor polynomial. Oh, was there a point that we were focusing on? Yeah. At x equals a. 1 point. Yeah. And it gives you the best polynomial of that degree, meaning of degree up to n for the given function, fitting the given function. Remember this, class. I taught this trillion times I said this thing. Please remember this. This is beautiful. It was an awesome attempt. Great attempt. Great attempt. And there was even a handy formula. It was like some garbage like this. Nth Taylor polynomial at x equals a was f of a plus f prime of a over 1 factorial times x minus a plus f double prime of a over 2 factorial times x minus a all squared plus f triple prime. Okay, hey, Carrot Cat, VIP. Pay attention, folks. Carrot Cat, VIP. Kiss the ring. Okay, here we go. So, that was a great attempt. Why is it an attempt? Let's go into that. I need to do an example. I'll do an example real fast, okay? We'll do the example. Class, what is the term for Taylor polynomial at x equals 0? Class, what's that called? McDonald, McCulkin, McLaurin, McDougall. McLaren. Exactly. I taught you something. McMuffin. Macaco. McMuffin. McFloral. Exactly. McChicken. That's right. 0 is the Maclaurin constant. Oh. Mandalorian. I don't know why that popped into my brain, but might as well. Everyone gets credit, right? Everyone gets credit. Okay, let's go look. I'm gonna look at the Taylor approximations, polynomial approximations of cosine x. And what we're gonna do, we're gonna observe something. We're gonna observe something. All right, we're gonna have to go into the third eye. Third eye time. Third eye time. Let's see. Where is the neuroimaging technology? Okay, you know what? We upgraded. It's in here now. We upgraded it. All right, everyone get ready to go into the third eye. Get ready. All right. Am I going to be able to do this successfully? Let's see here. We go to calc. Oh, everyone's here. Crow, Toaster, B-Boy, you, all of you. Awesome. Oh, nice. Nice try, B-Boy. Nice try. All right. Awesome. Everyone's so excited. Come on in. Carrot Cat. VIP Carrot Cat. One of the original students was here at the beginning of this crazy experiment. All right. Let's go to Calc 2. Okay. So. Oh, you're still here? You guys following me? Hi, Rack. How's it going? Everybody? Tori? What's up? All right. Okay. What a beautiful class I've got here. All right. Okay, so I gotta teach you now. I can still teach you from inside of my consciousness. which is where we are. We're at the seat of my consciousness. And now look, my consciousness, I'm able to do many great things with my consciousness. Okay. So here we have, wait, the emote wall is still active? Oh no. Oh, what a disaster. Okay. Okay, so now look at this class. What we've got on the page here is cosine X. All right? Cosine X. Can we see my cursor? Yeah. Okay, this is cosine X, class. This is the graph of cosine X. Check that out. You want me to zoom out? No problem. Let me do that for you. Using only my consciousness. Look, it just keeps going forever. Up and down, up and down. That's what cosine is like. It's periodic. Okay? Beautiful. Beautiful. What I'm now going to put up, look over here. Look at this monstrosity. Look at this monstrosity. I don't know if it's possible for me to zoom in on that. But put your face up against the screen. It's a sum. It starts at 0 and it goes to 10. Let me fix that. Let me do, instead of 10, let me do 3. All right? And now I'm going to plot it. Okay? This here is the, it looks like the third. Okay? It's not the third because when you put 3 in here, you'll get x to the 6th power. This is going to be the 6th McDougall polynomial. 6th Taylor polynomial of cosine at the origin, folks. I'm going to click this here button. Boom. Look at that. Unactive, deactivated, activated. Look at this blue polynomial. Look how good it is at 0. Can you tell the difference? I sure can't. That's the 6th McDougall approximation. All right, let's crank this 3 up here. Let's look at here. You see this mouse? Let's click that. Let's make it bigger. 3? No, not 3. Wait. Okay. Let's make it 8. Whoa, do you see that? You see how it changed? Look at that. Look at the blue curve. It stays for a longer time. It stays together close to cosine X for a longer period of time when I made it an 8. Okay, let me do 20. Come on, clicker. Come on, clicker. Can you guys see what I'm struggling with here? I can't click on the 8 anymore. Oh, there we go. There we go. Wrong side. Ah, good. Good. Let's make it a 20. Woo! Now look. Wait. I can hear Tori asking, where is the blue curve? The blue curve disappeared. Right, Tori? Wrong. Let me zoom out. Holy cow, look at how many humps the 20th one agrees with. That's insane. That's insane. But it's still not the same. You see over here. Over here, Tori. The blue curve goes over here, but cosine keeps going like this. So these are not the same. Okay. Let's go and make it 40. Let's make it a 40. Nice, first try. Oh, wow. Tori, look. Can you tell the difference between the blue curve and the dotted one? Look, there's no difference. You can't even tell that there's two graphs. Hold on, let me zoom out. Let me zoom out. Let me zoom out. Let me zoom out. Bam. Look at how many humps. Look at the humps. It's getting better and better. You're gaining more and more territory. Tori. Coincidence? I think not. 100. It's gonna take a while. Boom. Even more territory. Wait. It's just messing up now. It's messing up. Believe me, it would just keep going. Something's wrong. Something's wrong. It's messing up. 100 is too much. 100 is too much. $80. There you go. There you go. Even more territory. Awesome. Okay, so what did we learn? This thing is really good at trying to be Cosine X. This one's really good. But then this one, Tori. This is even better. And it's even better for a longer period of time. There's a longer interval on which it's good. And then $100. This one is way better. It's so good that Desmos couldn't even believe it. And the territory on which it's a good approximation just keeps expanding. The territory on which this approximation is good keeps expanding. These were the observations. This is what we just learned from this Desmos exercise. From the seat of my consciousness, empirically, we learned that when you up this end number, as you keep increasing it, you get a better and better looking polynomial for cosine for a better and better, huger and huger interval. Okay? All right. Let's go back to the real world. All of you. Nice to meet you, new person. Gath, incredible human being. All of you. BPS, the person who made this technology possible, hacked right into my consciousness. Tori, the person who's asking all these brilliant questions. Amazing. Okay. See you guys on the other side. All right? Great. How do I get out of here? Okay. Fantastic. So, what's the take home? We know what we just did. These Taylor approximations, when you crank up the degree, get better and better for a longer period of time at looking like cosine X. So maybe we should just say maybe this. Look how big that look where I ended. Where did I end the Taylor polynomial? I never ended. I just didn't end. I kept going. Maybe if you do that, it's equal. Straight up equal. Cosine X. Maybe we should just say that. And if you look at the thing on the left-hand side, what kind of a thing is this? Let me write it out. It's definitely an infinite series. Infinite series. Because of the infinite up there. Let me write the first couple terms. Dot, dot, dot. What kind of thing is this? It's an infinite series, but it has powers of X in it. It's an infinite series, and it's got these powers of X. It's like an infinite degree polynomial. It's like a series of powers. Of a variable. And it comes about by trying to say, look, if you make infinite accuracy on these Taylor approximations, you will get cosine X across the board. This appears to be true no matter what X is. The whole territory. On the whole territory, x-axis, cosine X will agree with this infinite one. At least that's what the pattern looked like. As I increase this thing, more and more territory getting taken care of by this beautiful Taylor approximation. So no matter what x is, we're tempted to say that the left-hand side, which is a new kind of object, is the right-hand side. Okay? So I'm now going to give you a definition of the left-hand kind of object. Left-hand side. A power series. Is an expression. Is an infinite series of the form okay, n equals something, just start, yeah. We will typically start at n equals 0, but like summation notation, doesn't really matter what you do. Okay? It's an infinite series of the form. Infinite sum of numbers times powers of x. Okay? Don't get fixated on this right now. Know what it is in words. It's an infinite sum of powers of x. Some of the coefficients can be 0. These are called the coefficients. Some of the coefficients can be 0. Sometimes only even powers of x might show up. Sometimes only odd powers. Sometimes some weird combination of them. I don't care. Every time you write down an infinite, possibly infinite, sum of powers of x, that's what a power series is. It's like an infinite degree polynomial. Okay, that's my first definition. Let me look at the chat to see if anyone's confused by this definition. It's a new type of object. We're just talking about a new type of math object. Let's see. Bossed. People are talking about Grubhub. Quarantine. Is this math guy? Is this true for other stuff beside cosine X? Stay tuned, math guy. Stay tuned. I'm about to show you another example that we already know. Okay, I'm going to show you an example that we already know just in a second here. I just want to know if people understand what the concept of a power series is. I'll now show you an example of a power series. Here's a power series. BMP's power series. You go and make an example for yourself, okay? Look, here's one. 1 plus 2x squared plus 4x cubed plus 5x plus... Let me write it in summation notation for you. I'll start my index at 0. Fine. Doesn't matter. Okay. I guess technically you're supposed to go like this. Take a look at that. Does that look right, class? Plug in some numbers and see if you agree. Looks right to me. Okay. Good. Infinite sum of powers. It's a power series. I get to name it that because I just brought it out of my imagination. Why don't you make your own? Go make your own. Be creative. Okay, go make your own. Go. Don't just make up your own set of coefficients and put powers of x next to them. And make it infinite. Go. Do it. Don't just follow what everyone else is doing. Make your own. Awesome. Okay. So now I'm going to show you a second example. Another example. Okay, another example. We're going to go over time a little bit, class. Don't worry. Go home, watch the video later for the rest of it. Okay? Another example. Hey, remember from geometric series? Remember from geometric series? Here's a geometric series. Right? Right? And if r is smaller than 1 in absolute value, you actually get to put something on the other side. You can know, Math Mama. You know what this geometric series adds up to. 1 over 1 minus r. Terms and conditions. Now, I'm gonna make a move that half the class, somehow, I don't know why this happens, but half the class will think that this is some kind of magic trick. I'm gonna go through this old content, and I'm just gonna replace the symbol R with something called X. Please just hold on to your seats. I'm just gonna do that real fast. For some reason, it's the most controversial thing ever. Terms and conditions. Let me write this terms and conditions as a picture. All right, now I'm gonna go visualize this. Now, it's getting kind of hot in here, so I don't want to go into the third eye because it's gonna make me sweat. All right, so what I'll do is I'll bring my consciousness outside into the real world, and we'll go do it that way. Oh, but why is the screen all small? Whatever. You know what? Whatever. Just, I don't want to talk about it. Oh my god. Here we go. Here we go. Here we go. Here we go. Thank you, Crow. Thank you. Loyal customer. Gotta really do this every time. Okay. Okay, I'm gonna fix these now. I'm gonna do the power series for I'm gonna do the geometric series example. It's way simpler. I'm not gonna do 80. I'll do 3 first. And this is just powers of x. X to the n. Okay. And cosine x is not the right one. We're not looking at cosine x. We are looking at 1 divided by 1 minus x. And we're looking near x equals 0. The green curve. The green curve why is this doing this? There. Okay. The green curve. Right here. Look, that's 1 over 1 minus x. That's its graph. It has an asymptote right here. Look, plug x equals 1. That's going to be a problem. Yeah? If I zoom out, you got an asymptote. But now look, I will activate the blue curve. This one. Look, it's 1 plus x squared plus x cubed, and then stop. Boom! Check out that cubic. It's pretty good. It's pretty good for the original function. All right, let's crank up the degree of this polynomial. 10. Math BM Pogs in the chat. Look at this closeness. Look at this. You can't even tell the difference between the blue and the green. And look how good it is. It's good for like all of this period of time right here. It's good for all of this. And you see which x's that corresponds to? Look, x is 0 to all of this, and x is up until about here. That's pretty good. Good amount of territory. Let me now crank this up even higher. Damn it, I had it. Okay. 20. Oh! Check that out. Even better. Look, this divergence point, it crept over to the left. And for all of this, you and I can't tell the difference. It's good. It's good all the way up until like 1, basically. See? Look, can't even tell the difference. Where's the blue curve? Where's the blue? Where's the green? I can't see anything. On this side, clearly something drastic happens. And clearly, this pattern was not seen with cosine x's example. There was no place to the left where the approximations, the better and better approximations, would suddenly diverge from the actual function. Increase it to 100 and break Desmos. Okay, my fat fingers have to press the 20. Ah, there you go. 100. Whoa! Look at that accuracy. Look at that point. Look at that. Look. Look how close 1 plus x squared plus x cubed plus x, all the way to the partial sum, all the way to x to the 100. look how close that polynomial is to the green curve, starting at around x equals -1 up until x equals 1. Because there's an asymptote here, so you don't even talk about what happens afterwards. Okay? Notice that more territory is good. Or the polynomial is witnessing the original function for a bigger and bigger interval. And it's very plausible to believe or to expect that if I crank this up to 200, the agreement will even inch closer to -1. Whew! That's basically a sharp turn. It's not, because polynomials are differentiable functions, so there's no sharp turns. But this is really starting to look like -1 is some kind of controversial point for this power series. It's not a power series, but for these Taylor approximations when they're trying to fit the original function. And so what we're witnessing here is the following perhaps fact. So perhaps what you have when you have a power series perhaps what happens is that the power series only looks like the function when certain terms and conditions apply. You get a straight up equality, not an approximation anymore. When you crank up the power to infinity, however, at the expense of a region where the power series is actually a function. So that's what we're going to understand. We're going to understand when is a power series actually a function. That's the content of this week. How to plug numbers in to a power series. When is it valid to plug numbers in to a power series? That's the goal of this week. But first, all we need to know is what a power series is. It's an infinite polynomial. Okay, go to sleep, class. Go back to sleep, whatever you were doing. We'll continue with this next time. Okay. Thank you all for showing up. Much appreciated. Yep, celebrations. Class is over. I'm sure you're all... Macaco. Bad. Whoa, what is this? What is this? Get it out of my face. Who's doing this? Who's doing this? Okay. All right, class. See you later. Credits. I gotta do the credits. Who are my teacher's pets this time? Gary asked for a twisted cubic when I was in the middle of lecture. Yeah, good job. Way to go. There you go. 23 minutes ago. You're probably long gone. There you go, Gary. Have your fun. Someone asked me to juggle in the middle of lecture. Thor asked me to juggle. Yeah. To hell with that. Credits. Who was teacher's pet? Let's look. Dopamine time. That's right. Who was it? Kappa and Anonymous. Special thanks to Tori for asking all the questions that I definitely heard her ask. They were not just me pretending to be an ideal student, feeding myself questions. Okay. All the people who attended. B-boy, will the approximation stay good past the asymptote? No. And B-boy, there's a good reason for that. Because polynomials they never have asymptotes. So there's never going to be a polynomial that mimics an asymptote. BMP, this is starting to get boring. I don't FW graphs. Oh, great. I don't FW graphs. Oh, it's getting boring? Okay. There you go. All right, what's next? Who else gets the dopamine? Okay, B-boy. Math mama. All the usual suspects are here. Just a human. Actually, with just a human, I'm not sure. I'm thinking just a human comes in the beginning of class and then just turns the computer off and comes back at the end of class. I've never seen just a human ask a single good question. They just sort of hang out in the beginning at the end. Did I get that right? Is that an accurate summary, like a description of you? Good. Hangs mate in one. Business mogul. All right. Shrek. Shrek, I'm gonna have to call you sometime this week. We're gonna talk. We're gonna talk on the secure line. Okay, Shrek? Wednesday. I'm gonna call you. On the secure line, you're gonna indicate that you understand just what a power series is. Okay. Who else was here? Who else gets dopamine? Go Pokes. Go Pokes gets an infinitesimal amount of dopamine. They spammed BM Pog at one point. All right, Carrot Cat was here. One of the original students in this experiment. Awesome Discord technique. Great chat etiquette. Insane contributor. VIP. That's a diamond. Whatever. Okay. Hot tamale. You asked a question on Discord? No. No, you didn't. No. Lying. Hot tamale lying. DMs? Next. All right, the mods, BPS. That's right, there's BPS. I did medbay scan. Okay, so did everyone get their dopamine for today? Everyone feel good about themselves? What about Rack? Wait, Rack is one of these generals. Rack and Shrek. They hold up the class when I call. They're the only reason I still have hope for this class. Rack and Shrek. Okay. So I think everyone got their... Oh, Battlestorm. Now let me go see what Battlestorm contributed. Let me scroll up the chat. Let me catch up. Here, let me go even further back in chat and see if there's anything valuable that Battlestorm contributed. Wentz looks nice. I was a little scared to stay there because I thought it would be like Parker. Wonderful contribution to class, Battling Storm. I'm not even gonna read that one. Exclamation point, sleep. Okay, there's still 30 people here. We're gonna vote. Should Battling Storm get in the credits or not? Okay, we're gonna vote. Because this was just, I didn't see anything good in there. All right, let's vote on this. Let's just vote on this and then go home, okay? Go do your exam, okay? Okay, we're gonna do a 2-minute poll. Go. Start the poll. The poll is the matter at hand is the issue of Battlestorm and whether they deserve to be in the credits. All in favor, vote yes. All opposed, vote no. It's a close race. It's a close race. We gotta wait for those mail-in ballots to get in here. Last minute. Come on. It's a close one. Nail biter. Wow. This is incredible. Okay, it's not that close. Go ahead and make it closer. Be trolls and make it interesting. Don't make it so one-sided. Okay, well, the problem is no one's voting because no one's here. Let's face up to it, okay? Fess up to it. There's no one here. Okay, and so Battlestorm actually made it because of low voter turnout. Okay, that's what happened here. This stream is a microcosm of the real world. All right, everyone wants to go to Melko? Let's go to Melko. Let's go to Melko. All right, we'll go to Melko. Wait, did he get... He got 69%? Are you serious? Wait, that's not even... Man, what a terrible classroom this is. This is one of the worst classrooms ever. Okay. Man, I hope there are no administrators in there. Okay. Hey, what about Crow? Coming in with a cash. All right, here's the credits. And as the credits go, we're gonna go raid Melko. We're gonna go kiss the ring. We're gonna pay our dues. Crow. No, it's just sugar. No one knows what that is. B-boy, math mama, just a human. Hangs mate in one. Rack, Shrek. Go pokes. Students, go take that exam. Try your best. Go. I believe in you. Parrot cat. Hot tamale. Geometric series full of lies. Don't try. Don't even try that. Don't even try to pull that on me. A divergent geometric series full of lies. Battlestorm. Corruption. Okay? Let's go. Let's get the raid going. Let's go to Prof. Melko. Spread the power of Power Series. All right? Everyone respect? Respect each other? Go have fun in Melko's chat. All right. Okay, raid this thing now.
Cities and tribes, the tests and the supplies they need. We're going to protect vulnerable populations who are at...
Zip it, Joe. We have a raid. Thanks, BMP, for the raid.
most at risk from this.
Appreciate you. Welcome on in. We are cringe level 1000. You're welcome. We are listening to President-elect Biden's remarks on COVID-19 that he just gave a few hours ago. So we're going to watch